Okay, so now my unit 2 is typically measurement and data. So during unit 2, we always practice our basic multiplication and division strategies, but I do start to introduce multiplication of larger numbers. We'll talk division in another video. So you'll notice the first strategy I introduce is that jump to a landmark number. So during and toward the end of unit 1 and unit 2, I always try to really reinforce those place value strategies, because this is going to be much more efficient, obviously, than drawing 34 dots 3 times, or even doing 34 plus 34 plus 34. That works really well for this. But if it was 34 times 8 or 34 times 9, that addition quickly becomes a problem for our striving learners. So if they're going to jump to a landmark number with this larger number, not a mental math fact, especially for fourth graders who are new to larger numbers like this, then we talk about how, well, a number that's close to 34 is, could we start at 30 times 3? A lot of my students will understand that if I know 3 times 3, I know 30 times 3, because that is a concept we have practiced. They also like to talk about how they can cover up that 0. Yes, I know it's a math trick. But again, if you're reinforcing those place value strategies, you can teach them some of those tricks as long as their vocabulary tells you that they're accurate and strong in place value. So if they cover up that 0, they know 3 times 3, or they can count up to that is 9. Now, I never let them say, and then we just add the 0, because 9 plus 0 is still 9. So mine have to be very specific about, we put the 0 back, or we put the 0 in the ones place. So now we're not going to add another 30, because that would jump up very quickly. So we are going to add our 3 here, because that was the number that stayed the same. So we would do 93. And at this point, I would ask them, how do I know where to stop? Well, if this is 30 times 3, this is 31. So I have to keep going till I'm at 34. So you have 96, 99, 102. So here's 30, 31, 32, 33, 34. So our answer product would be that 102. The next one, again, reinforces place value. So we are going to do a break apart strategy. And I often introduce these 2 all in one day. I don't do all 4 because it becomes very overwhelming. So I'm going to do a different fact, but if you want to do the same one, you could certainly show 34 times 3. Again, I've done it both ways. It doesn't seem for most of my students to matter, especially if your students are not ready for this yet. It doesn't seem to matter yet. So we talk about how instead of breaking apart this number, you could do 29 times 4 plus a 29 times 4, but that doesn't really help you. So, but it does help you if you can break the larger number. So this is where I kind of fake it. I put on that dog and pony show, and I ask them, oh, so is it just a 2 and a 9? And hopefully they'll remind you that the 2's value is not a 2, that it's actually a 20. The rule in my classroom is if you break one number, the other number has to stay the same. We'll use break apart strategies and addition and subtraction as well. So again, they usually will use that cover up the 0 strategy, where if I know 2 times 8 is 16, that helps me solve this. Or I know if I count by 20, 40, 60, 80, 100 all the way 8 times, they all end in a 0. So that's probably the most common mistake they make with this one, is they forget to put the 0 in the ones place. Now, 9 times 8 can be a really tricky one. This is where you can talk about that 9's multiple tower and some of the patterns they've found in that one. Yes, some of them will know the 9's tricks on their hands. I don't teach that strategy necessarily. I would probably ask them, do you know 10 times 8? And if usually they can tell me 80, then we count backward to 72. Now, this is where they can give you, we in unit 3 would not have done addition concepts yet, but hopefully they can tell you, I always ask them, so are you going to tell your 5th grade teacher that the answer is 160, 72? hopefully they will be able to tell you that you're going to add them together. And this is where you can kind of see what are the strategies that they were introduced to or strong in third grade. So a lot of mine will say, well, you add it together, but they want to start over here, which you can do if you're going to do 160 plus 70 is 230 plus 2 more. So I usually encourage them towards starting in the ones place with a 0 plus a 2 is a 2. A 6 plus a 7, sorry about that number combination. You may want to change that one. Is 13, but we talk about how the whole 13 does not go down because it's really 130. Then the 1 would come up and give us an extra 100 and give us 232 as your answer product there. A couple days later, once I feel like they're confident in this one during our 10-minute math time, again, I can show you that in another video, how I use that. I know these videos get long, but I also know that I've used these strategies so many times that my 5th grade teachers are so appreciative of understanding exactly the background knowledge my students will have because it's consistent every year and it's consistent across all 4 or 5 of our 4th grade classrooms. Now, my unit 4 in math will be geometry, and area and perimeter are a part of that. Don't ask me why they're not a part of measurement, but with area model, we start with our rectangle. Now, I'm very picky about this. I do not let them cut the rectangle right down the middle. I do ask them to cut it. I tell them cut it more like a bed. So this is where you'd put your pillow, and this is where your blanket, and the bed always faces this way. The reasoning for that is when we break one of these numbers, so yes, this is also a break apart strategy, but it breaks it down into pieces students can find success with. Is if I'm going to break this, I will ask them, so do I just put a 5 and a 2? And hopefully someone will tell me, no, the 5's value is not just a 5, it's actually a 50. So we put our 50 and our 2 up top, and then the shorter sides are 6. Well, if this side is 6, then we know this is 6. And we know which sides to put them on because 6 is smaller, and this is the smaller side. 52 is bigger, so the 52 goes up here. So this is where you do your multiplication, where you would do your 50 times 6. So you can do your 50 plus 50 is 100 and count up from there. You can do your cover up the 0. 5 times 6 is 30. Put your 0 back. Please don't let them say that you add the 0 because we're not adding the 0. We're putting it in the ones place because if we counted by 50s, 50, 100, 150, 200, those multiples will always end in a 0. Then we come over here and we can do our 6 times 2 is 12. Now, hopefully, again, they will recognize 300 plus 12 would give you your 312. Not all of my 4th graders understand that if I have zeros over here in the 10s and the 1s, that these 2 digits would naturally just replace that. So sometimes we do have to do a little bit of our addition strategies as well. My last strategy, and this one's a little controversial, and I know that. I don't touch the algorithm in 4th grade. It is not required by my state standards. So if it is required by yours, I'll make another short video or I can add on to this one. But I actually do a rounding strategy with my students because, again, all of these quickly become mental math strategies, especially these 2. Sometimes this will as well become quickly a mental math strategy, especially for division later with larger numbers. But I go to a rounding strategy. The tricky part about this is it doesn't work for every single multiplication problem. It would not be the best strategy for 52 times 6 because you would take it back to the 50 times 6 and then add the 2 times 6. And that's really a break apart or area model strategy. That's not necessarily a rounding strategy. So, but again, if they recognize that's how to do it and they are strong in that strategy, that's what's important. So with the 18, I would round it up to a 20 times a 4 because that should become a mental math strategy eventually for my students. Or they can tell me, well, I know 2 times 4 is 8, and I put the 0 in the ones place. But we talk about how we actually had 18 and we made it into a 20. So it's going to be too big. So we are going to take away So 20 take away 18 is 2. So I'm going to put my 2 here. But of course, if I break that number, the other number stays the same. I got to take away a 2 times a 4. So 80 take away an 8 would give you a 72. Now, if your district requires the algorithm in 4th grade, totally respect that. I have taught it myself. What I would encourage is start with these 4 strategies and then move on. Do the algorithm last, because if they are not strong in that place value, then the algorithm is quickly going to be just a math trick. Now, all I did was I cut a piece out of another anchor chart. Yes, that makes me very cheap, but also these anchor charts are a little bit expensive. My district provides a couple of the Post-it pads, but not a ton of them. So also you could use like an 8.5 by 11. Once you want them to move on from a strategy, it's easy to cover it up. So if you have no idea what I'm talking about, sorry, my H kind of became part of my M there, what I am talking about with the American algorithm. So we are one of the only countries that solves this way, and I can see why when I'm trying to teach it to 4th grade and I want to pull my hair out, because for my more advanced learners who this is easily understood, this also becomes easily understood. For my learners who are still striving to get to some of more of our place value concepts, this is very confusing. Quickly becomes a math trick, and if they make a mistake, they have no ability to fix it. So we talk about with any algorithm, we always start in the ones place with 8 times 4. Now, some of my students will know that's 32. Some of them might have to do a multiple tower over here. So we talk about how in 32, the 2 is in the ones place, so that's what we put there. The 3 is in the tens place. So we're going to put the 3 up here, knowing it's not really a 3, it's actually a 30, which is what makes this strategy so confusing. Because yes, now you're going to do your diagonal across to the tens place, but a lot of students who don't have that place value will instinctively think you really are doing 4 times 1, and you're not. You're doing 4 times 10, which is 40, plus 30, which is 70, and that's why you're putting a 7 in the tens place. So this quickly becomes a very confusing strategy for your students, but I do understand if your state requires you to teach this, maybe even have it mastered in 4th grade, that it can be added to your chart. I would just add it later personally.